Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So in this video, I'm going to present solutions to problem 69 to 71 in hydraulics. Problem 69. Benzene of specific gravity 0.877 flows through a 100 mm diameter pipe at a mean velocity of 3 meters per second. Compute first volume flow rate in liters per second. This is Q. The weight flow rate Q times specific weight, and the mass flow rate Q times density. So for the solution, uh, Q equals pi over 4 diameter square area of circle times mean velocity. So everything is given. So pi over 4 times zero point 0.1 square times 3 meters per second. So we multiply further by 1,000 liters per cubic meter to convert Q to liters per second. So in liters per second, 23.56 liters per second. 69.2 weight flow rate is Q times specific weight. Since we have already computed Q, so convert that to cubic meter per second, 0.02356 cubic meter per second. The specific weight is specific gravity times specific weight of water, 9,000 specific gravity of benzene times specific weight of water, 9,810 newtons per cubic meter. So the unit would be newtons per second. So 202.7 newtons per second. Then the mass flow rate is Q times density. The density is 877 kilograms per cubic meter, 0.877 times 1000 kilograms per cubic meter density of water. So Q times density is 0.02356 cubic meter per second times 877 kilograms per cubic meter. So therefore this is kilogram per second, the mass flow rate. So that's it for this problem. Problem 70. Air at 30 degrees Celsius and 100 kilopascals absolute flows through a 150 mm by 300 mm rectangular duct at 15 newtons per second. Compute the average velocity, so that's V, and the volume flux or the discharge. So for the solution, uh, this is weight flow rate, 15 newtons per second. So it is equal to Q times specific weight of air, and Q is area times mean velocity. So area times mean velocity times specific weight of air, because Q is area times mean velocity, and this is gamma, specific weight of air. The area is given, then specific weight of air at 30 degrees Celsius and 100 kilopascals absolute uh, will be computed later. So let's substitute area 0.15 times zero point 0.3 times mean velocity times gamma of air is 15 newtons per second. Therefore, V times gamma of air is equal to 1000 over 3 newton per meter square times second. That should be the unit, because this is meters per second and this is newton per cubic meter. So newton per meter square times second. For specific weight of air, it is absolute pressure of air times G over gas constant of air times absolute temperature in kelvins. So that's the formula, remember, from the first part of fluid mechanics. So P is, let's convert this to pascals, absolute, or pascals. So 100,000 times 9.81. Gas constant of air is 287 newtons per Newton meter per kilogram kelvins, then times temperature in kelvins, 30 degrees Celsius plus 273, to convert that to kelvins or absolute temperature in kelvins. So computing for specific weight of air, it is equal to 11.281 newtons per cubic meter. We can now compute the mean velocity. We substitute the value of specific weight of air here. So V times 11.281 newtons per cubic meter equals 1000 over 3 newton per meter square second. So cancel newton, then cubic meter per meter square is meter per second. So mean velocity is equal to 29.55 meters per second. Then for the volume flow rate, or Q, we substitute into this equation because specific weight of air has been found 11.281. So Q times 11.281 newtons per cubic meter equals 15 newtons per second. So cancel newtons, so unit would be cubic meter per second. So Q equals 1.330 cubic meter per second. Problem 71, oil of specific gravity 0.86 enters at section 1 at 0.06 newtons per second to lubricate a thrust bearing. The 10 centimeter diameter bearing plates are 2 millimeters apart. Assuming steady flow, compute the outlet average velocity and the outlet volume flow rate. Since the substance that enters is oil, we consider liquids as incompressible, therefore the rate or volume flow rate Q in, or the volume flow rate that enters, equals the volume flow rate that goes out of the system. So Q in equals Q out. So this is Q in and that's Q out. And remember, this is 10 cm diameter, so this is a plate. So imagine that it is a circular cylinder. The area is equal to circumference times thickness, or circumference times height. That's the area. Then times mean velocity here. That's the outlet average velocity. And Q in gamma is 0.06 newtons per second. So the circumference, by the way, of the outlet is pi times diameter. Diameter is 0.1 meter, and the thickness or height is 0.002 meter. To convert everything to meters and just meters, so that the units of average velocity would be meters per second, and volume flow rate in cubic meters per second. So this is the principle. Q for incompressible fluids such as liquids, Q gamma in equals Q gamma out, and it is 0.06 newtons per second, or in fact Q in equals Q out only. But because this is given, then from here we can compute Q, because gamma is 0.86 times 9,810 newtons per cubic meter. So area O times VO times gamma out equals 0.06 newtons per second. Area out is, as I said, circumference times thickness. So pi times 0.01, that's the circumference of the cylinder. This is a cylinder of height 2 mm. Thickness 0.002 or height 0.002 times average outlet velocity. Specific weight of oil is 0.86 specific gravity times specific weight of water 9810 newtons per cubic meter equals 0.06 newtons per second. So from here we can compute the outlet average velocity, and it is equal to 0.01132 meter per second. And for the volume flux, we just compute Q here. So Q times gamma 0.869810 equals 0.06. So Q times 0.86 times 9810 newtons per cubic meter equals 0.06 newtons per second. Cancel newtons, so Q will have units of cubic meter per second. And it is equal to Q in, which is equal to Q out, equals 7.112 times 10 to the negative 6 cubic meter per second. If we multiply this by 1000, it becomes liter per second. Multiply by 1000 again, it becomes milliliter per second. So in milliliter per second, it is 7.112 milliliter per second. So that's it for this problem.